Today we are going to discuss about the coordinate of center of mass of different object. To see, firstly we will talk about the symmetrical and uniform distributed object. So any geometrical symmetrical object of uniform density. So center of mass is geometrical center of the object. What are the geometrical center? That will be the center of mass. For example, if circle is there, circular ring is there, so their geometrical center is center of circle. If sphere is there, so that is also distributed symmetrical. So for circle, center of mass. Also for if you go for the sphere, the sphere and circle, center of mass will be circle, circular ring or sphere. The center of mass is center of the circle or center of the sphere. Same way if we will go for the square, the center of mass will be the center of this geometrical center where diagonals are intersecting. So this will be the center of mass, Cm. When we go for the rectangular object, for rectangular object, so their center of mass is what? Center of this. So this will be the center of mass. Mean geometrical center. Symmetrical object if you are taking, the geometrical center will be the center of mass. Equilateral triangle. The equilateral triangle is also center of mass will be centroid. So this will be the center of mass, centroid. Okay. Or any triangle, the center of mass will be the centroid of that triangle. So this will be the center of mass. The center of mass of a symmetrical object. How we are finding? What will be the geometrical center of that object? That will be the center of mass. If we take cube, the cube has also the geometrical center of cube where diagonals are intersecting. So that will be the center of mass. So cube also you can say the geometrical center of cube will be the center of mass, geometrical center. If object is geometrically symmetrical and uniform distributed, so their geometrical center will be the center of mass. When there is not symmetrical distribution, some object they have divided along x-axis or along y-axis unsymmetrically. So how we will find the geometrical center of mass? Here isosceles triangle of plate. So this is also symmetrical. So here we can say if height is h, if you are taking center here, so center of mass position will be at y coordinate, you can say h upon 3. So if you are taking center from here, so it will lie on the perpendicular bisector at h upon 3 above. So that will be the isosceles triangle plate. So isosceles triangle plate center of mass will be at height h upon 3. Total height is h. Same way if we will go for the right angle triangle. So right angle triangular plate, when we will talk, then what happens? Center of mass. So here this right angular plate I have taken. Suppose length base is A, height is B. So center of mass will be, if this taken as origin, This will be the center of mass position. X coordinate will be at a by 3 and y coordinate will be at b by 3. So this will be the position of center of mass for right angle triangular plate. So for right angular triangular plate, you can see here this will be at a by 3. This is the center of mass and y coordinate at b by 3. Here this would be the center. Remember, isosceles triangle. So this I have taken as origin. So x coordinate will be 0 and y coordinate of center of mass will be at h by 3. So this I have told about the some specific center of mass of object. Some special you have to know about the center of mass. For example, thin circular ring. So see here, if this I have taken as origin, then what would be the center of mass? So x coordinate, this is symmetrical. Remember one thing, if object is symmetrical both sides, so that line will be the center of mass will lie on that line. So mean at that line, if center of mass lie, so x coordinate, if this I have taken origin, this is x axis, this is y axis, this is x axis and this is y axis. So then center x coordinate will be lie on that line, which is about which the ring is symmetrical. So x coordinate will be what? X coordinate of center mass will be 0 because this I have taken origin, and y coordinate, if we will take y coordinate of center of mass is this is 2r upon 3. So center of mass for when we will talk about the ring, so this is equal to 2r upon pi. So this distance will be 2r upon pi. This will be the center of mass of semicircular ring. So for semicircular ring, what we have seen, if this center O I have taken as origin, this is x axis, this is y axis, so this will lie above how much? 2r upon pi. So 2r upon pi distance above will be the center of mass of circular ring. But when we have taken a thin semicircular disc, this is ring, only mass is concentrated here. When we will talk about the thin semicircular disc, so it will lies downward, center to downward. What will be the, this is this I have taken as origin, this is symmetrical about this, so center of mass lies on this line. So x coordinate of this will be 0. What about the y coordinate? If radius is r, then y coordinate of this is 4r upon 3 pi. So 4r upon 3 pi. This is the distance where center of mass lies. That is 4r upon 3 pi. This distance is 4r upon 3 pi. So remember, thin semicircular ring, center of mass 2r upon pi, and for thin circular disc, center of mass lies at distance from center of this semicircular disc, that is 4r upon 3 pi. When we will talk about the हेमिस्फेरिकल सेल, ठीक है, एक फुटबॉल को हाफ कट कर दो, ठीक है, तो हेमिस्फेरिकल सेल, तो व्हेन वी विल गो फॉर द सेंटर ऑफ मास, तो एक्स कोऑर्डिनेट विल बी दिस आई हैव, और center I have taken as origin, so x coordinate will be 0 because it is symmetrical. What will be the y coordinate? Y coordinate of this is r by 2, just center. that is R by 2. This will be the center of mass. So hemispherical cell, the center of mass is at R by 2 from the center along y coordinate. This will be the for hemispherical cell. We will talk about the solid hemisphere. So for solid hemisphere, what happen? The center of mass will be, if center is this taken as origin and horizontal plane lies on horizontal surface, that time x coordinate will be 0 but y coordinate at 3r upon 8. 3r upon 8. So this is for the solid hemispherical cell, solid hemisphere. So for solid hemisphere, the center of mass is at height 3r upon 8. So remember, semicircular ring 2r upon pi, thin semicircular disc 4r upon 3 pi, hemispherical cell to r upon 2, and solid sphere, that is 3r upon 8. This is for hemisphere. For circular ring or circular disc, okay, that is symmetrical. Okay, तो geometrical center, तो geometrical center, because they are symmetrical both about x-axis and y-axis. So geometrical center means center of sphere. So if they are semicircular, full circular, circular ring or circular disc or hemispheric spherical cell and solid sphere, so all have center of that sphere, that will be the center of mass. But when hemisphere, I have shown here ring, this is disc, this is hemispherical cell, and this is for solid sphere. We will talk about hollow circular cone of right type, solid right circular cone. This is hollow circular cone. For this, what happen? If this I have taken as center, so center of mass will be, for hollow, it will be at h by 3 total height. So center of mass, x coordinate, if this center, about this both it is symmetrical, so x coordinate will be 0. This I have taken x axis, this I have taken as y axis, so y coordinate is h by 3. So this is for the hollow right circular cone. For solids, solid mass will be downward, concentration more, it will slide below than previous one. So that is h by 4, center of mass. This we have taken x axis, this I have taken as y axis. So center of mass for solid cylinder. This is for solid cylinder. This is solid cylinder. Y coordinate at h by 4 from the basic plane. When we will talk about the hollow or solid cylinder, here hollow and solid circular cone different, but for hollow or solid cylinder, that is symmetrical, both hollow and solid about x-axis and about y-axis also. So geometrical center, so geometrical center mean at h by 2. So this we have taken x-axis and this is y-axis. So then center of mass, x coordinate will be 0 and y coordinate will be at h by 2. Geometrical center will be the center of mass for solid cylinder or hollow cylinder. Here I have described about the cone, hollow and solid, and hollow and solid cylinder where will be the center of mass. One problem is there. There are 4 uniform solid cubes of age 10 cm, 20 cm, 30 cm, 40 cm kept on the ground, touching each other in order. Locate the center of mass. Very interesting question is there. See here, 4 uniform solid cubes. Remember, one has length 10 10, this has length 20 20, this has length 30, and this is 30. Cube is there. This has 40 and 40. Let this 10 and 10. 10 and 10. Same cube. What will be the volume of this? Volume is equal to A cube. 10 cube. 1000 cm cube. If you will see volume of this, 20 cube. 8000 cm cube. If you will see volume of this third cube, that is 30 A cube. 27,000 cm cube. And volume of fourth, 40 cube. 64,000 cm cube. Suppose mass of this is m. Mass of cube, side 10 cm, is m kg. What will the mass of all have uniform? What we know? Mass is equal to volume into density. Uniform solid, all have density same. All cube have same density. Mean mass directly proportional to volume. Mass directly proportional to volume. Because all density, all cube have density same. So what happened? 1000, 8000, 8 times the mass of second cube side 20 centimeter is equal to how much? This is 8 times, so that will be 8m. M, so this has mass 8m. 8m, I am writing here. 27 times, so this has mass 27m, and this will be the mass how much? 64m. So this will be the mass of the cube, because all have uniform solid cube, mean all have same density. The mass of second cube, same way mass of third cube, side 30 cm, so that will be 27m, and mass of fourth cube, side 40 cm, so that is 64. The M1m, M2 8m. See about the x coordinate of the center of mass of different cubes. So first cube position, the 10th, this is position of 5 cm. And x1 is equal to 5. What about x2? You can see here, this is 10 and this is 20. So this will be the 20. x2 is equal to 20. Different positions, center, x coordinate. You can see here, this is 30 and this 30 half 15. So 30 any, this is 40, this is 50. This will be the x3 is 45. See, you can see here 10, 20, 30, 40, 50, 60, 30 and 30 half 15. 30 plus 15, 45. What will be the coordinate, x coordinate of this? You can see here, this is 60 and this is 40. So 60, 40 half, that is 20, mean this will be the 80. So 70, you can see here 90. So x4 is 80. Okay, I have shown the x coordinate of these. First C1, this is C2, this is C3 and this is C4. X coordinate is 5 for this 20, 45 and 80. What will be the y coordinate? You can see y coordinate midpoint. तो y coordinate for first, पहले के लिए क्या होगा बच्चों y coordinate? तो y coordinate is y1 is equal to 5. सेकेंड के लिए इसका हाफ, दिस विल बी द सेकेंड के लिए. तो सेकेंड के लिए y coordinate is 10. सी यहाँ पर जस्ट हाफ ऑफ दिस बिकॉज ऑल हैव केप्ट ऑन x axis. तो हाफ ऑफ दिस, तो 30 का हाफ क्या होगा बच्चों? दिस विल बी द सेंटर. तो दैट विल कम y3 is 30 half, that is 15. एंड इसका कितना होगा 40 हाफ, दैट इज 20. तो x coordinate y coordinate we have written. So this has coordinate 80, 40. This has coordinate 45, comma 15. This has coordinate 20, comma 10, and this has coordinate 5, comma 5. So what will be the x coordinate of center of mass? m1 x1 m2 x2. तो m into x1, x1 is 5 cm, m2 8m into 20, third 27m mass, coordinate x coordinate 45, and next one is 64m and x coordinate is 80 upon total mass m plus 8m plus 27m plus 64m. 5m I have taken common, तो 1 plus 5 4 जा, तो 8 into 4 32, 5 9 जा, 9 7 जा 30 63. Here 5 16, 16 4 जा 64. Total divided by this is 100. mm cancel. 5 multiplied by okay. This has come 0 0. Sorry, 1300 is has come. So this has come 1300 to 13.5. See, you can see here the x coordinate of center of mass is 60 at this. So 10 plus 2 30. So 1300 multiplied by 5 divided by 100. So 16 cm will be the center of x coordinate of center of mass of this. What will be the y coordinate? So for y coordinate what happen? Here I am writing y coordinate. So m1 y1 ycm m1 y1, so m into 5 plus m into 10 8. Third mass 27 m into 15 plus 64 m into 40 divided by m plus 8 m plus 27 m plus 64 m. m1 y1 plus m2 y2 plus m3 y3, 5 m I have taken common, so 1 plus 2 8 are 16, 81, 5 8 are 512 divided by 100 m. mm cancel, 5 upon 1000, add this 2 plus 1, ठीक है, ऐड करेंगे 1, ठीक है, so this will come about that will come 30.5. So see, this has come 354. So 5 into this 520. This will come 17.7 cm. So see here, 64, 20. This 81, 5 we have taken common. This is 256. We have added 354, so this is 17.7. So coordinate of center of mass this system is x coordinate is 65 and y coordinate is 17.7 cm. So answer will be center of mass. What will be the center of mass? X coordinate is 65 cm and y coordinate is 17.7 cm. So this will be the 4 uniform they have kept together, and location from first we have taken as origin, then coordinate will 65 cm, comma 17.7 cm.